Hi, and welcome to What's the Word, an electrical industry podcast. I'm your host, Zach Hartle, and I'm joined, as always, by Jason Cox. And we're here to just have relevant conversations with people from all over the electrical industry. Our goal is simple. It's to learn something new and bring information to everyone here listening to the show. Thank you so much for joining us today. Today's episode is no exception. It's about a very important topic, electrical shock and arc flash, with Terry Becker from TWBESC Electrical Safety Consultants. We're going to chat about a lot of acronyms today, so take a look in the description or show notes to see a list of those acronyms. Thanks so much for joining us.
Welcome to the show, Terry.
Thanks, Jason. Glad to be here.
So, Terry, can you tell us a little bit about your background and how you got into this side of the electrical industry?
Yeah, I'm an electrical engineer by background. I started my career in oil and gas, and then that's where I first found out about the arc flash and shock hazard at a conference I went to, and there was a presentation on NFPA 70E, Standard for Electrical Safety in the Workplace. This is back in 2005. So I was an electrical engineer doing sort of standard electrical engineering for oil and gas and engineering consulting before 2005. And at the time, I was actually working for Encana Corporation, which everyone will know in Alberta. And that's when I found out about arc flash and shock, and that was the change in my career. At that point, I, somehow a switch turned on, forgive using the analogy, and I said, geez, these two hazards, arc flash and shock, we haven't done anything. I didn't even know what arc flash was in 2005. I knew what shock was, but as an electrical engineer, I'd really never focused any attention on it, when in reality, I should have been focusing attention on it as part of my job for Encana at the time. Right. So that set me off on a new journey and a new mission in my career after 2005. And there's a lot more to that story, which, again, we can talk about if need be in the podcast.
So just jumping in there right away, you mentioned the NFPA. Can you kind of talk about the difference or the similarities about the NFPA and the CSA here for our listeners in Canada and I guess in America?
Yeah, and again, the NFPA 70, when I found out about it, was this 2004 edition, and that was back in 05. And we didn't have CSA Z462 at the time. So part of my job at Encana was to manage risk related to our use of electricity in our business. And then we had these two hazards. And so I did a bit of benchmarking with other oil and gas companies, and then I phoned CSA. And after about 10 people, I got the right gentleman. And I said, are you aware of this NFPA 70 standard for electrical safety in the workplace? Believe it or not, CSA knew about it in 05, right? And they said, well, yeah, we're actually aware of that. You're not the only one that's been inquiring. And we're going to have this new C Code Part 1 rule that's going to be added to the 2006 code. And I said, what? It was strange. There was convergence on the topic, but the convergence was actually a problem because the new rule, Rule 2306, called for a new arc flash and shock warning label to be installed on electrical equipment, and we didn't even know what arc flash was. And we hadn't actually identified arc flash in the workplace or the shock hazard, right? So that's what set me off. So what happened is CSA said, well, we signed an MOU with NFPA to harmonize standards for North America, and we're going to create CSA Z462 Workplace Electrical Safety Standard. Do you want to be on that tech committee as the first, vice chair and a voting member? And I said, well, at this time, by this time at Encana, I had things sort of rolling that we needed to deal with these hazards. So it was sort of a natural that I said yes. So we did not have Z462 published in Canada until January 2009. And at that time, we were probably fully harmonized with NFPA 70E, but that's changed. So we're now in our 5th edition of Z462, published January 2021. I'd say we're, giving a number, 90% harmonized with 70E, but we've made some of our own improvements, right? Because we have that ability to deviate. We do not have to stay harmonized with 70E, and we have not. So the latest edition does have some interesting changes that are not in NFPA 70E.
Okay, but wonderful that they both are very similar. It's not apples and oranges, it's two types of apples, and maybe the 70E will borrow from the CSA in the future. We don't know, right?
Well, what'll happen is we do try and submit our changes through their public comments process, right? And in turn, we track their public comments and then bring those back to Z462. So right now we're already into the 2024 edition, right? And as far as reviewing changes. So for Z462, we had over 50 dockets, but unfortunately, most of those dockets came from tech committee members, not the public. Whereas in the US, they typically range from 300 to 500 public comments every revision. The standard's a lot more mature, maybe a lot more adopted, and a lot more awareness in industry. Where in Canada, I think we still lack awareness that the Z462 workplace electrical safety standard is available and can be used. So we really haven't had a lot of public comments. And then we are going to attempt to say harmonize, but sometimes they reject our public comments for changes that we like, and they don't accept them. Then we retain those in CSA Z462 and sort of vice versa, right? But we're going to, in the 2024 edition, I think, make sure we try and take some of the good things that they have that we don't have and continue to push to them some of the things that we bring forward. The challenge is these tech committees, it's industry. It's not 70, it's not NFPA or CSA group, it's industry that structures these tech committees, and people vote, right? And there's different people and there are different sort of understanding or drivers for what they want to see happen in these standards, right? So that's not necessarily a good thing, because sometimes some really good content doesn't get voted in.
Well, and it definitely can be self-serving and move in a direction that might not be best for the nature of the Safety Act. If I was looking at starting a business, or I'm new to the electrical industry as a contractor, what do I need to know? As far, like, obviously the CSA has rules and legislation in place. What's the top thing that you think that new contractors should be aware of as they're entering into the business of being an electrical contractor?
So obviously we're in Alberta, so I'll speak to Alberta, right? And it starts with, occupational health and safety regulations. So if you're a one-person contractor, a 5 or 1,000-person contractor, there's this overarching legal obligation in Part 2 of Alberta's OH&S regulations for hazard identification and application of risk control methods. So that applies if I'm a one-person contractor, like I said, 5 or 1,000. So if you start your own company, you've got to protect yourself. You're the CEO, the president, the safety officer, right, and the worker. Right now, obviously, you're just one person. But with respect to all workplace hazards, Alberta says that you have to manage those, identify them, and then if you can't eliminate exposure, implement risk control methods. The other challenge in Alberta, it's not a challenge, the other part of the regulations that is very strict is Part 15, control of hazardous energy, right, which is lockout, tagout. And then in Alberta, we have Part 18, personal protective equipment, and arc flash shows up in Part 18. So right now, it's a legal requirement that if a qualified person's exposed to arc flash, that the employer has to provide arc flash PPE. But that's the only portion in Alberta's regulations that's specific to arc flash. There's no specific legislation related to the electric shock hazard other than Part 15, control of hazardous energy. It'll indicate electricity, but it doesn't uniquely identify the shock hazard. So small contractor, large contractor, the regulations are your legal obligation, and all workplace hazards, including shock and arc flash, have to be identified. And if we can't eliminate exposure, then apply risk control methods. And guess where we get those risk control methods from? The CSA Z462 Workplace Electrical Safety Standard.
And so when we're looking at risk control, I would think the two things that are going to come to be would be PPE and then a procedure to complete a process.
So again, I'll use CSA Z462 because it's the toolbox. And I tell everybody Z462 is a toolbox for electricians, right? Specifically to our topic today, but there's other task qualified workers too. So the toolbox provides prescriptive policy requirements, right? And the first policy is to eliminate exposure. And if you can't establish an electrically safe work condition, lockout, tagout for electrical equipment, then you have to have justification for energized work. And then you have to complete a discrete work task shock risk assessment and an arc flash risk assessment to identify additional protective measures, which is boundaries to apply and the arc flash and shock PP tools and equipment. So there's the PP aspect of Z462. the arc flash and shock risk assessments. But overarching this is you need to have a risk assessment procedure so that we consider likelihood of occurrence. So what I find is that when there's training on Z462, it just says, oh, just do the shock risk assessment and the arc flash risk assessment. So that's boundaries in PPE, but it neglects the topic of likelihood of occurrence. And a true risk assessment procedure considers potential severity of injury or damage to health and the likelihood of occurrence. And all of this is in Z462. So again, it's all about the work task. I talk about this that, well, Terry, it's about the electrical equipment. No, it's not. It's about the work task first. And then you need to know the maximum nominal voltage that you'll perform the work task at on this electrical equipment. So work task, maximum nominal voltage, because that determines if you can receive a shock or we can sustain an abnormal arcing fault and have an arc flash result. And there's a sort of a first rule for arc flash. If there's no abnormal arcing fault, there's no arc flash. And then when I talk about this, there's normal arcing in energized electrical equipment, but by design, the arcs are extinguished so they don't become arc flashes, right? So it's a long-winded answer to your question, but for a contractor, they're gonna need arc flash and shock PPE, 1 person, 5 person, 1,000 person. And really, when I've talked about this, the first PPE that should be procured is rubber insulating gloves with leather protectors, then arc flash PPE, but you need both. Ultimately, you're going to need both, right? Rubber insulating gloves and leather protectors, the right class number, right? Class 0, max use 1,000 volts AC for low voltage. And that should be standard kit. And apprentices should be exposed to this PPE. They should be told about this PPE. And again, some of these tools in Z462 can be communicated to an apprentice in school, because that's where we need to start. And then out there, the journeymen that are out there, we need to get them what I call compliant arc flash and shock training so that they get the right information and they maybe don't get the wrong information. And that's another topic.
All right. Now I'm going to jump way back here.
Yeah.
So what I need from you is, I know how industry works, and I know it's changed since the day I got my tickets. It's definitely gotten safer. But can you tell our listeners, being the contractor to the green apprentice, what justified means? You can only work on live equipment if the work is justified. Real simply explain to that apprentice right now who doesn't think that he's doing something wrong, tell him what justified work on live circuits is.
Justified work is diagnostics and troubleshooting and isolation related work tasks. We want to eliminate energized repair or alteration, right? We want to eliminate that. And Rule 2304 in the Canadian Electrical Code is called disconnection. So we actually have this occupational health and safety rule in our safe installation standard, which my opinion is it should be deleted, but that's another topic. And it says no repair or alteration energized, but you got to read the whole rule. That C code, you got to read these rules and you got to interpret them, right? Don't take them carte blanche necessarily. So that Rule 2304 says disconnection, no repair alteration, comma, unless it's infeasible. And then Appendix B in the CE Code Part 1 points to Z462. So now back to Z462. Justification for energized electrical work. It lists 3 elements of justification, right? Increased risk or hazard, infeasibility due to equipment design or operational limitations, or the voltage is less than or equal to 30 volts AC or less than or equal to 60 volts DC. So there's no arc flash and shock hazard if we're equal to or less than 30 volts AC or 60 volts DC. You can still get an arcing fault, but that's not an arc flash. So justification would be diagnostics and troubleshooting due to equipment design. How else do we make this equipment work if we don't go and check for voltage, right? And then when we isolate it, it's energized electrical work to test for absence of voltage. That's one of the myths, is that I just opened the circuit breaker. I don't need any of this PPE. That's false, right? Until you test for absence of voltage with an approved test instrument, it's energized work to test for absence. And that's all justified work. So diagnostics, power control circuits, right? Again, isolation work tasks. Now, isolation work tasks, what are those? Well, opening the circuit breaker, right? Or the disconnect switch, but that's operating electrical equipment. So there's a difference between diagnostics, repair, operating, and isolation work tasks. So diagnostics, completely approved, go ahead, right? And an apprentice is taught to use their test instruments to do that, right? There's other specialized testing that's also authorized. And we actually isolate the electrical equipment, put voltage back on it. But we need to do this diagnostics and testing to make sure the equipment will operate to its identified parameters, right? And then it's operating correctly. And then when it's not, we can get it operating again. So that's all justified, right? We want to eliminate the repair and alteration. And we also need to do those isolation work tasks, which are racking in or out low voltage power circuit breakers, racking in or out high voltage power circuit breakers, and for high voltage, installing temporary protected grounds, right? So to summarize, it is not against the law to do energized electrical work. It isn't, right? We want to use risk assessment as a tool to help us make decisions, and higher risk work performed energized is repair or alteration.
So with those things you're mentioning there and what you mentioned before, obviously one of the first things you're going to want for a lot of that work is to have the rubber gloves with the leather protectors. So just to take a step back to those for a sec, if I want to get a pair of approved rubber gloves with leather protectors, how much do they cost and where do I go to get them?
So a pair of Class 0, now this one thing too, all this arc flash and shock PPE is not CSA approved, right? So there's the other thing. You need to be aware, well, I need CSA approved rubber insulating gloves with leather protectors. No, because we don't, and we will never have CSA standards for arc flash and shock PPE. So the first thing is I need to know that I'm, going to purchase an ASTM, American Society of Test Material Standard approved rubber insulating glove and leather protector system, right? And then I go to a vendor and I'm looking at probably, all in, because I need the storage bag. The storage bag, I got to protect the glove. I got to transport it from, the shop to the work location. I can put the bag down on the ground. The gloves don't get dirty. So the Class 0 max use 1,000 volts AC and 1,500 volts DC, because DC can shock us, right? Will cost you probably about $200, maybe $225 per pair, right? Ultimately, you need 2 pairs because you have to get these rubber insulating gloves dielectrically retested every 6 months. So if you have a pair of gloves in for test and you need to do energized work, you need a second set and you have to stagger the test dates. So just a little more than the cost, just ASTM approval, about $200, $225 in the storage bag, rubber insulating glove with the leather protector. Now that leather protector is a unique leather protector. You can't just get a leather glove from the local hardware store, right? So $225, the dielectric retest costs about $20 every 6 months from labs. There's lab in Calgary and a lab in Edmonton that do the actual testing.
And that's not so bad to obviously ensure they're maintained and still working correctly, right? I was going to ask about the cost. I was a little worried there, but $20 every 6 months isn't so bad. So we've already addressed this a little bit, but we need to get the education coming in early in the apprenticeship. But aside from that formal training that you would receive in the apprenticeship system, is there anything else that people can look at for training if they want more information?
So again, I've been trying to advocate that we need, better training at the apprenticeship level. And unfortunately, the C Code Part 1 is pretty thick. But, this topic of arc flash and shock, my opinion, should start in the first year all the way through the 4th. Every year, there's like a refresher on arc flash and shock hazards. Then the apprentice gets their journeyman's ticket. They're out in industry. So at this point, the employer is obligated to provide training, a broad spectrum of occupational health and safety training. So unique, again, to electricians, after they're trained in school and they get their journeyman's ticket, they need ongoing training. Now, Z462, again, where do we go to get some information on training? So Z462 says that we should have arc flash and shock training every 3 years. Because guess what? Z462 cycles every 3 years, just like the C Code Part 1. And we aligned the cycling so we're in parallel with the C Code Part 1. I'm glad it worked out that way. So every 3 years, my opinion is, an apprentice that might be out in industry, working for an employer, they would attend independent arc flash and shock training, much like I offer, right? So I offer web-based or instructor-led arc flash and shock training based on CSA Z462, right? So that training should be at least every 3 years. Now, the other issue with Z462, though, within the training requirement in clause 4.1, it says that we need to train on emergency release of a worker that's being shocked every year, right? So then what I recommend is the employer, and Z462 mandatory requires it, shall have an electrical safety program. And that program is, again, a documented system that directs activities related to, work on energized electrical equipment, and it addresses training. So within that program, it should say, hey, once a year, we need to have a little bit of a meeting, right? Maybe we combine it with our annual safety meeting, or maybe we have monthly safety meetings, and every 6 months, we have ad hoc training. This is what's being missed in industry. Not only, ad hoc training about emergency release of a worker that's being shocked, but ad hoc training on those rubber insulating gloves and leather protectors. So formal training, 8-hour course, low voltage, 16-hour course, low and high voltage, electrical safety program role and orientation training. So once an employer develops policies, you need to train your workers on it. And that would be this electrical safety program role and orientation training. And then blend annual refresher or ad hoc training on some of the key concepts. And I said rubber insulating gloves and leather protectors because when I'm out doing external electrical safety audits, guess what I find? The gloves maybe aren't even being worn, they're still in the bag, or the test frequency is out of date, right? And for shock, that will save an electrician's life. The current was always flowing through the hands, right? So we need training to be formalized in school, apprentice every year. Then again, the journeyman electrician under the employer's responsibility is provided arc flash and shock training every 3 years, but then integrate this ad hoc short training, on some of the key topics throughout the year to keep it current, to keep it fresh, and to remind that journey person electrician and apprentices that are out there doing their hours that this PPE, you need to identify it, you need to pre-use check and inspect it, and then wear it. And then the risk to you is low risk that you'll be exposed to shock and or arc flash, right? There's no zero risk, but I do quote with rubber insulating gloves and leather protectors, if they're stored properly, they're dielectrically tested every 6 months, you pre-use air and visual check the rubber insulating glove and inspect the leather protector, you will not get current flow through your hands into your body ever again.
Harry, one of the things you mentioned there is doing audits and your observations in industry about what's being done correctly and incorrectly. Where in industry are you seeing electrical safety processes and procedures done well?
Well, that's a good question. And, I classify, the companies that I work for as institutional, commercial, and industrial. So remember, my journey started in 2005 for a large oil and gas company, right? And I'll make a blunt statement. The oil and gas industry is the most safest industry in this country. It is, because trust me, I've now been exposed to other industries, and just general safety is not as intense as it is in the oil and gas industry. All right. So industrial has been leading the way. And I'll be blunt. The oil and gas industry started this whole thing off. And I was one of the catalysts of that. I was the catalyst, right? And then unfortunately, commercial and institutional lagged behind this and identifying these two hazards. And I find that they have weaker occupational health and safety management systems than what I was used to in the oil and gas industry. And so they're lagging behind. Some of them have funding problems, which I do recognize because they're taxpayer funded. So they, safety shouldn't need a budget, but safety needs a budget. So when I'm out doing external electrical safety audits, now I finally did get back out there, right, last fall. And I did a large industrial external electrical safety audit. And then I did a large, what I'll call, institutional, which I'll say municipality, right? Wastewater, water treatment, right? And so the industrial was, the outcome of the audit was the industrial was ahead of the municipality, right? But the industrial end user still had issues because with safety, it's called Plan, Do, Check, Act. And it's a philosophy. It's one of many philosophies in occupational health and safety. Now, that philosophy is consistent with CSA Z45001, which is an occupational health and safety management system standard that Canada adopted, which was ISO 45001. So the audit tells us what's happening, and industrials lead the way. Then I'd say, institutional, which would be municipalities, large universities, and school boards. And then I'd say commercial, manufacturing sites, small commercial, large commercial buildings with, warehouses, and then the like, they lag at the bottom of the list on who's done, what with respect to arc flash and shock, and who's done it well, and then who's auditing it, right? And that's the challenge. If you don't audit safety, you don't know if it's working, if those risk control methods are actually working. And there's another topic that's relevant to this is electrical supervisors. There's a whole other topic. And what they are unfortunately troubled with today is doing a lot of administrative work and lacking getting into the field with the electricians, right? So, but industrial's been leading the way.
Okay, great.
How would you say Canada fares compared to the rest of the world? Is there any countries we should be trying to emulate a little bit more?
So, these are some really good questions because they're all relevant, and I've tracked all this, right? So when I was doing my benchmarking back in 2005, it was Canada and US, right? And then it sort of expanded because, I don't know, it seems that at that time in the early 2000s, arc flash and shock started to become relevant internationally, right? Now, the NFPA in the US has, in my opinion, a broader reach internationally, right? US corporations take things with them because the countries they go to do not have OH&S regulations and they don't have standards. So right now, NFPA 70E is used either voluntarily or potentially adopted by a country internationally, right? So Australia, New Zealand, I think Brazil or Argentina adopted 70E and it's translated into Spanish, right? We translated Z462 into French. So South Africa uses NFPA 70E, and then Asia would, maybe 70E, but that's a whole other topic. The Middle East, where the US has a strong presence due to oil and gas, right, would be using 70E. And then Europe has now moved, as I would suspect, the EU has moved to developing their own documents. Australia and New Zealand have as well. So earlier on, when I was, getting into this, and if you haven't recognized, got a lot of passion I want to share, I actually presented in Australia on CSA Z462 and Canada adopting it to influence and provide information, right? So I went to Australia 3 times and presented. I presented in Canada, across Canada at conferences, and I present in the US. So Canada is, we quickly went from nothing to, a significant change. And so Z462 has made a significant change. And Canada, in 10 years, went from really nothing, and these rubber insulating gloves with leather protectors for journeyman electricians not being known or worn at all, to, an escalated, basis of it, but we still got a long ways to go. So Canada is in good shape. I'd say the US, is farther along in their journey because NFPA 70E first published in 1979, but it really didn't change to its current format until 2000, 2004. Mm-hmm. So we have an international issue with our, with these hazards not being identified. So right now, there's literally hundreds of thousands of shocks occurring right now globally, right? As far as arc flashes, not as many because countries don't have regulations. They don't maybe even have proper training for journeyman electricians. So it's someone that's just trained, right? And in general, the biggest problem internationally in some countries would be there's no OH&S regulations. So Canada is now up at this top tier, I guess. We'd align with the US, we'd align with Australia and New Zealand, obviously the Commonwealth link to Australia and New Zealand as well.
And it sounds like, maybe the issue here, North America, let's say, isn't having the standards and the documents in place. It's maybe bringing the awareness to everyone about how to follow them correctly, get the training out there, like we've said, right?
So again, I mentioned, institutional, commercial, industrial. Mm-hmm. And, the last 10 years, the awareness of Z462 has just ramped up. It has, right? And when I said, earlier that, commercial and institutional are lagging industrial, I sort of equated that to the fact that industrial, I think, has more liability under OH&S regulations, not that the other industries don't, but there's a lot more workers working at a work site potentially. So the liability of the employer increases when there's a total man hour increase, right? So again, Canada is moving through this, but we still have challenges because it's not practiced everywhere, and especially electrical contractors. Electrical contractors, they'll tell you they run a thin business as far as profit margins. But if you're running a contracting business, you're still making money. But forgive me for saying it, I think there's a lack of contractors wanting to spend money on arc flash and shock. And that's the training, because the training, it's going to cost you a certain amount of money per electrician, right? And if it's good training, you're going to get good value out of that. And I try to instill that when I do my training with the electricians. How do we field apply this information? And that's the differentiation of my training, by the way, is I just don't say, here's what's in Z462. I try and communicate the training through what I call an energized electrical job workflow, right? So again, we got a long ways to go. We need improvements in training in industry, but forgive me, it's next to impossible, because anybody can do arc flash and shock training in Canada, because there's no certification body certifying that training, and it's called buyer beware, right? And what I find is that the employers are not pre-qualifying companies that provide arc flash and shock training, and not pre-qualifying the instructor that, forgive me for saying it, that they're truly a CSA Z462 SME, such as I am, right? So again, we've got some work yet to do.
What's the documentation process in Canada if there is an arc flash, or more importantly, if there is a shock that happens? Do they get reported? Is it legislated that they get reported? I know that's a big issue we're having now.
Really good question. So under OH&S regulations, whether it's provincially, territorial, or federally, and more provincially, there's more systems in place, is under workers' compensation acts, right? An injury in the workplace has to be formally reported to the government, and the worker should seek medical aid. So for shocks, electricians have been shocked since we invented electricity, and they didn't report them. They accepted them. The American Electrician's Handbook, actually from 1942 to 1960, said use your fingers or stick a wire in your mouth, right? So we got this history, right? So electricians should have reported them first to their employer, and then they should have filled out a WCB and went to emergency. Every shock, you should have went to emergency, right? And been put on an EKG. So that's the first obligation, emergency response. Get the worker to emergency, fill out a WCB so you have insurance, right? Separately, the employer, right, now has another obligation. Under the Electricity Safety Acts or Safety Standards Acts across Canada, you have to report the electrical incident to the jurisdiction having authority for the CE Code Part 1, because they want to know if the incident was due to a lack of code compliance or equipment failure, right? So there's two legal obligations to report a shock and an arc flash. And if there's no injury and we have an abnormal arcing fault and arc flash, you would only report that arc flash with equipment damage to the jurisdiction having authority for the CE Code Part 1. And that has to be reported by a master electrician in our province, or other provinces, or a field safety representative in BC. And there's forms provided by Alberta Municipal Affairs for this province, or the TSBC in BC, just as an FYI. So that's a really good question, because I don't think that shocks have been reported. Well, they haven't been reported at all, or if they have been reported, just the WCB requirement, but not the jurisdiction having authority for the CE Code Part 1.
No, and I bringing that awareness to the shock hazard and reporting it is the only way that we are going to see improvements in that. I mean, and just as a side note for all our listeners here, if you do want to hear more about shock hazard or the long-term effects, which we call sequelae, take a listen to episode 3, where we have John Noel on, who's a huge advocate in the industry right now for shock hazard in the trade.
So I just want to comment on John. John approached me a year and a half ago because I talked about electric shock sequelae, but no one came forward. No electrician ever came forward. So I didn't talk about it a lot. Then John approached me because I support the Electrical Contract Association Alberta. I'm trying to support them. I'm trying to help their owners and get good information to their electricians, good training and electrical safety programs. John approached me and said, Terry, you've talked about this. I said, yeah, but no one's come forward. And he says, well, where can I get, diagnosed? I said, well, you got to go to the Sunnybrook, the Sunnybrook Health Sciences Center in Ontario. It's the only place that I know of that has an electrical injury program, but, and so he did. And he was diagnosed with sequela, but he has sequelae, which is multiple long-term effects. So then John, owning it, because he's impacted, he's no longer in the trade. It debilitated him. So he owned it, and he owned it because he had one WCB report for what he would tell you. I've been shocked 100 times, but he only had one WCB. So that's the important thing about shocks. You need to report it so that if you do have long-term sequelae, you're going to get insurance if you can no longer be in the trade. So this is new information, and it just hasn't been talked about because there's no electricians coming forward. Now, my opinion is, percentage-wise, if we did have some statistics, maybe less than 5% of electricians, maybe less than 1% may have sequela and sequelae, because the electrical current coming into our bodies is different for you or me, male or female, right? And therefore, it may not have the same, cumulative effect and cause sequelae. John did get sequelae. He's been diagnosed, and now he's owning it and sharing his story. And I've been working with him. We actually went to the IEEE Electrical Safety Workshop. I took John with me. We went down to Jacksonville in person. We wrote a paper and we had a poster. And ironically, the keynote speaker was a Dr. Lee and a Dr. Jeske from the University of Chicago, SETRI program. So that got some huge attention this year at that flagship electrical safety conference. And John was amazing, and he told his story. We had 20, 30 people at our poster session, right? And it was really engaging. So short-term effects of shock are immediate. You're going to feel pain, or forgive me, be electrocuted. The long-term effects are not well understood still. So be aware of it. This is new information that we need to communicate to journeyman electricians out there.
Terry, I have to admit that when we started this podcast, I never thought that I would learn as much as I am. And our episode with John Noel it sounds really dramatic, but it was life-changing to realize just what kind of impacts can happen to people by being shocked. So that totally changed my perspective. And I've been in the trade now for close to 30 years. And you've brought it up here today, there's always a question about safety versus price, and you can't put a price on safety, but we do. So when we look at the workers in industry, what's the minimum PPE that we're looking at for these people to be doing their jobs on a daily basis?
So here's a general rule. If you're going to be doing energized electrical work tasks on 208 volt 3-phase electrical equipment or higher 3-phase electrical equipment, you're going to need shock PPE and arc flash PPE. So those minimum class 0 rubber insulating gloves with leather protectors. And then general rule, you need 8.0 calorie per centimeter squared full body arc flash PPE, which will be a coverall, an arc rated balaclava, an arc rated face shield, ear canal insert earplugs worn first before you put the balaclava on, CSA approved clear eyewear, because the arc rated face shield is not Z94 rated for shrapnel, right? Because they just didn't spend the money to get that certification. And you need ohm rated footwear, leather, right? And that would be the minimum shock and arc flash PPE for doing a voltage measurement at 208 volt 3-phase or 480 volt 3-phase or 600 or higher voltages. And then you decide if you need more using the tools in CSA Z462.
And what about underneath all of that? One thing I always remember from my days, but one thing I always remember is being told to only ever wear cotton underwear underneath my Carhartt pants or whatever it was. Is that a real thing or a myth?
No. So the problem with clothing worn underneath arc rated clothing is that if it is meltable, polyester, pot and poly blends, what happens is the PP that you're wearing that's arc rated is flame resistant fabric first that won't ignite when it's exposed to arc flash incident energy. And there's this very important value of incident energy, 1.2 calories per centimeter squared or higher will ignite flammable clothing. All right. So cotton is flammable clothing, cotton poly is flammable clothing, So what you need to wear underneath your arc rated coverall is 100% natural fiber clothing, cotton, wool, or silk, because the heat that comes through the outer layer, the temperature that of the incident energy, the plasma cloud, and this incident energy that's released, right? It's cooled by the outer garment before it gets to your skin. But the temperature that could get to your skin is 80 degrees Celsius, and that'll melt polyester, right? So you need to wear 100% natural fiber clothing, under arc rated clothing, and it's okay to have some minimal elastics to hold the underwear up. So whenever I talk about this, we still have to be reasonable and practicable about some of these things, because the underwear needs to be held up. Now, male and female need to talk about it, right? And so if you have a female journey person electrician, because we're getting more of them in the trade, which is, I think, a good thing, by the way, but we have to have a frank conversation that they've got to wear cotton underwear as well. They can't be wearing, I'll say it, like, polyester type, female underwear. They got to have cotton underwear. So male or female, same rules apply, because if it's polyester or poly blends, that heat from the arc flash, this sense energy, goes through the outer layer, and the outer layer is doing its job. It doesn't ignite, and it cools that plasma so that when it gets to your skin, right, the worst case burn injury you can receive. Now, here's another topic, is the arc thermal performance value of that garment is such that you can still get the 50% probability of the onset of a secondary burn, but you don't want the undergarments to melt as well.
Mm-hmm. And that was what I was always told, was it'll melt to your skin, which will
It
cause
will.
more of a problem, right? And the other one I always heard, since we're on the topic, is contact lenses in the event of an arc would melt to your eye. Is that myth or fact?
So my opinion would be that's probably fact, because what's happening is it's not the heat. Now, there is heat coming through the shield, right? So when you got the arc rated face shield, it's doing the same thing as the clothing, right? It's reducing the amount of heat that gets through the shield to get to your face. But we're still going to have potentially 80 degrees Celsius heat there, right? And you've got UVR light coming through. And that's what's going to be the big problem with your eyes. So you need to have prescription safety eyewear that you would wear. And I wouldn't recommend wearing contact lenses, right? We got the heat, we got the UVR light. Potential is those contact lenses, right? Forgive me, might melt.
All right. So I'm just throwing this out there. I never even thought of this, but like, if you're wearing a bra, like a lot of times bras, like women in the trades now, there's a whole lot of metal and support. Like that metal could be disastrous as well for the burn.
Okay. But remember, we've got to be reasonable and practical. So respectfully for females, their anatomy is different than a male, and they need to be comfortable when they're working, right? So this comes up with, well, Terry, can I wear metal rimmed glasses? Can I wear metal rimmed glasses? Or do I have to get, plastic rimmed, right? So there's two things here. There's the shock hazard, and then this thermal hazard related to arc flash. So metal rimmed glasses can be worn because your head should never go inside the restricted approach boundary for shock. It shouldn't be there. And that's called an inadvertent movement risk. 12 inches is restricted approach boundary for low voltage equipment. So the wire rim glasses are fine. But Terry, you said, what about the heat? Well, I've never heard of any incidents related to glasses heating and causing a specific burn to the face. Or now remember, the sample, there isn't a lot of female electricians out there, but and arc flashes are not happening at the frequency that some people may tell you they are. So we'll have no statistics. So you might get some heat coming through, and then the wire aspect of the female brassiere, I don't think it would heat up and become a substantial issue at all. So worker comfort, wires in brassieres, minimal elastics. We're getting way overkill on the topic. The bottom line is, I want arc rated clothing on an electrician to start out with. That's the first thing we need to do. And that's that minimum 8 calorie per centimeter squared, full body arc flash PP, 208 volt 3-phase or higher. And I got to mention it, 125 volt DC battery string output from a UPS or a higher voltage for larger UPSs, right? Same thing. And if we use Z462 and the arc flash PP category table method, that's what it would throw us into anyways. So a simple rule, and I'm really applying Z462 indirectly and just trying to say, there's that simple rule on minimum arc flash and shock PPE, right, for low voltage work. And then decide if you need an arc flash suit And if the voltage is higher, then you got to up the class to another class for a higher voltage of exposure.
But you've definitely demonstrated how you're using the CSI Z462 as your toolbox. I mean, it's you're always going back to it and just relating back to it. And I think that's something we all need to start really following that example.
Because I always say it's a toolbox, right? So if you're a journeyman electrician, well, if you're an apprentice, do you get a tool list and you go get those minimum tools? So a journeyman electrician needs Z462 and the tools that are in it to apply against, again, identifying if you're exposed to arc flash and shock, doing actual formal risk assessments for those, and then getting those boundaries, because the boundaries apply not only to the primary worker, but the boundaries keep unqualified, unprotected workers out that don't have the PP on. And if they come in the boundaries, they distract the worker, which increases the likelihood of you making a mistake when you flinch back because they surprise you when they come from behind you, right? So use the tools in Z462. But the problem is I don't think a lot of the training communicates it that way. I do. I said, here's a tool, and then apply it against a workflow. Jobs are given to journeyperson electricians, planned or reactive. And at that point, do electrical hazard identification against work tasks that you'll have to perform to do the job. And then use these tools in Z462 against the workflow, right? And we need documentation in the field as well. So Z462 requires that before a qualified person does energized work, that they have a documented energized electrical job safety plan, right? So these are the other tools in Z462. And I extract them and say, here's a job safety planning form. And then, and as far as what's going on in industry, if there is training and there is some policies, I don't think that journeyperson electricians are being told by their employers, fill this form out before you do energized work. And what they're doing is they're identifying if they're exposed, and they're telling themselves that I've got the right risk control methods to manage my personal risk.
Now, Terry, it's been a few years since I have put on a calorie rated suit. I remember it being big, clunky, heavy, earplugs, safety glasses, balaclava, and then the big hard hat with the orange face shield. Hot, sweaty, difficult to move in. How's things changed in that respect in the last couple years with the PPE for arc flash?
So again, I've been doing this independent electrical safety consulting now for 14 years. And the reason electricians called arc flash suits bomb suits 15 years ago, because they were big and bulky, right? So with people procuring this PPE, the vendors start to invest money, and well, not all the vendors. So there's the other thing. In arc flash PPE, not all vendors are alike, just like anything, right? So there's leaders in arc flash PPE, they're the innovators, and then other people follow. So what we've seen is the fabric technology has improved to lighter ounce weight per square yard and higher arc thermal performance value as a single layer garment. And then an arc flash suit is a multi-layered garment. It's called total system arc rating. So with that innovation in fabric, the manufacturers can layer lighter fabric, and the arc flash suits now are ultra lightweight. You would not believe it. I wish I could reach through the screen, right, and give you one of these suits. And then you could go, wow, from 10 years ago. So the arc flash suits are lighter weight. The actual single layers are lighter weight with a better ATPV. The other thing that happened with the arc rated face shields or the lenses in arc flash suit hoods, they transition from dark brown, dark green, light green to what's called true color gray now. So there's full visual light transmission, where before you put on those, you could barely see what you're working on, right? Which was a problem, because PPE should not increase the likelihood of you being exposed to the hazard we're trying to protect you from. So we've seen improvements in the ounce weight of the fabric to ATP performance. So lighter weight, more comfortable. The shields, now true color gray lens technology. So you can see the whole piece of electrical equipment with normal light. And it doesn't discolor wires, because the green discolored wires. So now that's all gone, right? The other thing that's happened is there's other aspects of this too, right, that are relative to if things go wrong, right? So one of the vendors now has an escape strap vest available that you would wear over your everyday wear with a 10-foot non-conductive strap that's weaved into the back like a harness. And I could use that to remove a worker that's been exposed to shock and release them Or if a worker's been exposed to arc flash and they're unfortunately in front of the equipment still, I could remove them. And that escape strap is also now included in an arc flash suit jacket. So the arc flash PP is more comfortable. It's the True Color Gray Lens technology, right? The escape strap. There's other innovations. There's what's called an extender rack, right? So for racking power circuit breakers, it's actually a telescopic hot stick, so you can shrink it to easily transport it, then expand it out 17 to 20 feet, and you turn the hot stick, and in turn, it's got a coupling that turns and racks the power circuit breaker in or out, with the worker now being potentially outside the arc flash boundary, right? There's other things too, like for instance, you need to test before touch with your test instrument, right? So this has been around for a while, but not many people know it. There's one of the leaders, right, in test instruments that's got a proving unit, right? It's a low voltage proving unit, finger safe, because it does give you a low energy AC output, and alternate gives you a DC output. So there's improvements in the test instruments, or in this case, an instrument to prove out your test instrument that you got a positive before you tested for absence and got 0, and then retest on a positive. And it's portable. You don't have to look for a receptacle. I'm up on a lift. How do I got to go down, I got to go up. So improving convenience for the journey person electrician on using these, policies and boundaries and things we want them to do is a huge thing. One last thing too, this has been around for a while. And again, probe extenders, right? So again, one of the vendors has probe extenders. So your hands are out of the box, right? They didn't put the guard on the end though. So you still need rubber insulating gloves. But when your hands were in the box, the problem was inadvertent movement and you couldn't see the work really well. Now with rubber insulating gloves and leather protectors on, that gets worse because you got more of a bulky glove and can't see the work. With the probe extenders, you hold the end with rubber insulating gloves, leather protectors, and probe in, right? So there's been improvements in arc flash PP, improvements on tools and equipment that are available. There's lots of information that you need to stay current with. And that's the challenge of the employer. But the journey person electrician, I think, is challenged because how do they find out about any of this? Well, you find out about this from someone like me that lives this and passionately wants to share and make this work out there. That's the problem. We need to make it easy or easier for the journey person electrician to be successful, right? And the PP improvements will now do that, but the employer has to budget and provide the new PP to the worker and replace the old PP. And that's a huge barrier.
Well said, Terry. If our listeners would like to learn more about TW Becker Electrical Safety Consulting, the services you provide, what's the best method for them to get a hold of you?
So my website, www.TWBESC.ca. I've got a great website. It talks all about who I am and a bit of information about my journey on there. And it tells you what I do, right? So it's really good. I've got a blog on there as well. So my blogs, and I've got publications. I write for the Electrical Line magazine, Kevin Burr's magazine. And if you're not signed up with him, sign up with him. His magazine's great. There's not only me, but there's a lot of good C code update content there too. So my website is the best place to go. Sign up and get on board with Electrical Line magazine for my articles. I've got a really good article coming out next edition on electrical hazard classification. That might be an entire other podcast, by the way. So my website, I'm also on LinkedIn, right? So I encourage journey person electricians to get on LinkedIn, right? I'll be honest with you. There's lots of jobs being offered on LinkedIn, all the way from professionals down to trades, right? So it's the business network. So I'm on LinkedIn. I'm posting there. I'm posting articles there. But my website, the number one location to find out more about me. And you can email me at any time if you've got quick questions. I'll answer them, right? So again, like I said, I'm providing electrical safety program development. That's my priority, is to get documentation in place as more than another formal toolbox for journey person electricians. I do external electrical safety audits, and I've got my brand of 1-day low voltage arc flash and shock training course and a 2-day low voltage and high voltage arc flash and shock training course.
Yeah, that's excellent, Terry. Just want to thank you so much for coming on the show today to chat with us. As always, we learned a ton. And as we mentioned, we could have gone down many, many more rabbit holes and spent a few hours talking about many of these topics. So I'm sure we'll have to have you back on the show one day to dig a little bit deeper into some of them.
Zach, Jason, I really want to thank both of you for for contacting me and giving me another venue to communicate. And I would be more than glad to come back in a future podcast or even a reoccurring podcast. Forgive me for putting the plug in for it. But we need to keep this topic front and center for journeyman personal electricians, right? And if we let it, we let it lag back, any of the gains, we'll see complacency and pullback. So thank you both for contacting me. Enjoyed the time answering questions with both of you today. Get in touch with me anytime.
Awesome. Thanks a lot, Terry.
Thank you both.
And to all our listeners out there, thank you once again for coming to listen to What's the Word, an electrical industry podcast. Come back again next month where we'll explore some more into the electrical trade. You can find us anywhere you find your podcasts, Apple, Spotify, Google, or YouTube, or check out our website, whatsthewordpodcast.com. Thanks so much for listening. Keep yourself safe out there. And if you can, someone else too.